Well, I'm back again. This is just a little bit more information about the power mic project, which I've been messing around with. Here is the power mic in front of me on the desk. I've not got it connected at the moment, but I want to give a bit more details as to exactly what went in it, because there is a wide choice of components that you can use, and if anyone wants to follow in my footsteps exactly, I thought I'd give you an indication as to exactly which parts I used. So I've got this little slideshow on the computer which will help remind me where I'm up to. So what we're looking at here is the Arduino board, which I know nothing about, but this is the little computer board that you get, and these other hang-on gadgets like the microphone board plug into these sockets which you can see on the side, and then you program it up. But I know nothing about that board, but this is just to introduce you to what we're talking about. So what I used here was this microphone board. This is the one I chose to use because it's got built-in processing. There's an assortment of these boards, and some of them have more processing than others. This one has a built-in audio compressor, and so it keeps the volume constant if you're moving away from the microphone. If you're closer on or further away from the microphone, it will attempt to keep the output at a constant level, which is perfect for what we want, because then if you like to speak a distance from the mic, or if you like to hold it close, it shouldn't make any difference. The output from the device should remain fairly constant. There's a few little settings on it, and here I'm showing how I've done it. There's some links there which you connect them to different places to alter the gain and the way it works. I've found for my use, I strapped the gain control and the little tag marked AR, connect them to the positive voltage supply. So on this I'm just showing it strapped, that the three of them are all linked together: positive voltage, the gain control and the AR control. So that gives you, if you follow the links, that will give you a 40 dB gain, and the compression at a particular setting, the AR compression, which I found was the best setting for my use. This is a rear view of the same board. The front view, on the front view you could see the microphone. This is the rear view, showing you some of the components and the little tiny integrated circuit which handles all the processing. So it's a really good bit of electronics for the job. Far more technical and complicated than the original amplifier board in the Turner Plus 3, or in any power mic you're likely to come across. It's a very sophisticated bit of processing. So that's the other side of the board, and that is the board to get, the AGC board. So when you look out for them, that's a picture of it, what it looks like, and that's the rear of it. This is the battery box I decided to get. This one holds two AAA batteries side by side, and it's more or less the same size as a little 9-volt battery that you would normally have in these microphones, because this Turner had the 9-volt battery, and that fits more or less exactly in the same hole, in the same holder that the 9-volt battery went in. So that is pretty much ideal, and these are easily obtained. So that was the battery pack holder for the two AAA batteries. I also needed a 0.1 microfarad capacitor. You can have more or less any value you like. But the idea of going for 0.1 microfarad was to give a bit of speech shaping, because if you listen to that microphone demonstration, it was a bit high pitched, and that was quite deliberate to give it that sound and to cut down on the low frequencies. You can put something like a 100 microfarad, a 10 microfarad, a 1 microfarad, but they will all allow the low frequency to pass through. And ideally, for our kind of use, you don't want the low frequencies. So you want a 0.1 microfarad, milder if possible, capacitor, and that isolates the output of the little processor board from the rest of what you connect it to. You've got to have a capacitor anyway to isolate it for safety. It's part of the requirements using that board, and so you're free to use whatever value you want, and the best to use, I found, is a 0.1. I also used a potentiometer, a brand new potentiometer, because working with an older power mic, the potentiometers do get worn and scratchy, and this one, it didn't quite fit inside the turner, because the one in the turner has got a very non-standard shaft, very, very thin, and it used a grub screw in the knob, and it was completely non-standard. So I replaced it with one of these more standard potentiometers that you come across in CB radios with a serrated top, and then I was able to put a spare knob from a CB radio on it. And the value I found best for my purpose was a 1 kilo ohm logarithmic scale. Again, it doesn't have to be logarithmic, but it gives it a better feel. Normally, volume controls on anything audio-wise tend to be logarithmic, so that you get an even increasing volume per degree of turn of the control. So a 1 kilo ohm logarithmic potentiometer was what I went for. This is a quick sketch of the circuit diagram, and you can see the 0.1 microfarad capacitor that is connected to the output of the little Arduino processor board. Then it connects to the top of the 1000 ohm log potentiometer. Another little variation I've been trying, at the bottom of the potentiometer, where normally you would connect the bottom end of the potentiometer to ground, I've put in there a 100 ohm resistor. Again, it's not critical, you can try different values, but the whole point was that when you turn the knob all the way down, I didn't want it to go completely to no output whatsoever. I still wanted some output to come from the device, so that you couldn't accidentally operate with the knob turned down and transmit a blank signal. I went for 100 ohms. It just seemed a nice round figure to give me a 10 to 1 reduction. But of course you can play around with that if you wish. Let's have a look at the next picture. Oh, that's it. That is it. So that is my slideshow. Good luck if you decide to follow in my footsteps and make one of these. As you've heard from the demonstration, it really works really well. It surprised my expectations. The quality of the voice that comes out of it, and the way the compressor works, which you may have noticed when I was using it. You could hear my breath because it was turning the level up in between my speaking, and you was hearing my breath. So it really is a superb compressor design. Okay, well, good luck if anybody decides to have a go and make one, and I don't think I can tell you any more about it.